Acids and bases. Essential questions. What are the differences between acids and bases? How are ions related to acids and bases? How do you test for acids and bases using pH? Acids, a solution that has an excess of H plus ions. From the Latin word acidus, which means sharp or sour. Characteristics: taste sour, react strongly with metals, dangerous and can burn your skin, turns blue litmus indicator red, the increase H plus ion concentration in a solution. Bases, a solution that has an excess of OH negative ions. Another word for base is alkali or alkaline. Characteristics of bases: their bitter taste, they have a slippery feel. Strong bases are very dangerous and can burn your skin. Turns red litmus indicator blue. Increase OH or hydroxide ion concentration in a solution. Think of some common household acids and bases. Common household acids are yogurt, vinegar, lemon juice, citric acid, oranges, orange juice, limes, jelly, pineapples, cranberry juice, milk, soda, batteries. Common household bases are bleach, antacids, toothpaste, baking powder, liquid or cream cleaner, oven cleaner, metal polish, soap, drain cleaner, ammonia, laundry detergent. Acids uses: acetic acid is vinegar, acetylsalicylic acid is aspirin, ascorbic acid is vitamin C, carbonic acid is in soft drinks, so sodas that you guys drink have acid in it. Citric acid is in citrus fruits and artificial flavorings. Hydrochloric acid is in stomach acid. It's what digests your food. Nitric acid is in fertilizers and explosives. Sulfuric acid is in car batteries. Bases uses: ammonium hydroxide is glass cleaner. Aluminum hydroxide is antacids and deodorants. Magnesium hydroxide is in laxatives and antacids. Sodium bicarbonate is in baking soda. Sodium carbonate is in dish detergent. Sodium hydroxide is in lye, oven and drain cleaners. Sodium hypochlorite is in bleach. If you look at these, we have hydroxide, 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 hydroxide. So all of these hydroxides right here are telling you that they are all bases. Acids and bases in nature. There are many strong acids and bases in nature. Fruits contain citric acid. Some of the acids and bases in nature are dangerous and used as poisons by insects and animals. So some plants, if an animal or an insect tries to eat it, it can have some poison in it, as well as some insects can spray or have venom. Many plants have acids and bases in their leaves, seeds, and even in their sap. Acids and bases in our bodies. Our stomach uses hydrochloric acid to help digest foods. and also kills bacteria that causes us to get sick. Our muscles produce lactic acid when we exercise. That's why they get sore. And our pancreas uses a base to help with digestion. Svante Arrhenius is a chemist who came up with a way to define acids and bases in 1887. He believed that acids were substances that produced hydrogen ions, H plus, in a solution, and bases were substances that produced hydroxide ions, OH minus, in solutions. Ions form when atoms lose or gain electrons to have full outer valence electron shells, the octet rule. Remember, we said 2, 8, 8. And here we have sodium. It has 11 total. It's got 1 valence electron out here. It's going to lose its valence electron. So since it loses an electron, which is a negative charge, it's going to become positive, and it's going to be a cation. So there's a positive there. Oxygen has 6 valence electrons. It wants to get to 8. So it's going to gain 2 electrons. Electrons have a negative charge, so now this oxygen has 2 additional electrons or 2 additional negative charges. And you see over here that oxygen is 2 minus. So the negative ions are anions, and the positive anions are cations. Remember, electrons have a negative charge. Cations lose electrons. That way they have a positive charge because they have more protons than electrons. And anions gain electrons. They have a negative charge because they have more electrons than protons. So for hydrogen, this is a Bohr model for hydrogen. It has 1 electron in its outer shell. It's going to want to lose that. So it has 1 valence electron, which it'll lose. When it loses its valence electron, it'll become positive, and that's going to be an anion. And the way that you draw a dot diagram for this is you just put this symbol, which is H, and then you put 1 dot for its valence electron. Oxygen, if we count up oxygen, it has 1, 2, 3, 4, 5, 6. It wants to get to the 8 to be happy. So it's going to gain 2 electrons. Currently has 6 valence electrons. For oxygen, it'd have oxygen. And we'd have 1, 2, 3, 4, 5, and 6. So that's when the hydrogens come over here. And if you have a hydrogen, it would share. Put another hydrogen here, and that would share. So then it has a full outer shell. Calcium, if we count that, calcium has 2 valence electrons. So calcium would look like this. Calcium wants to lose those 2 electrons to get back down to the 8, the octet rule. So when it loses those 2, it's going to be positive. And we have chlorine. If we count chlorine, it has 1, 2, 3, 4, 5, 6, 7 valence electrons. So chlorine look like this. In order to get to that octet rule with that 8 electron, Chlorine is going to gain an electron from something. If it gains the electron, it's going to have one more electrons than it has proton, so it's going to be negative. That one's going to be an anion. All right, acids and bases. Hydrogen ions, H plus, in water mixed with acetic compounds form hydronium ions. Here's an example of a hydronium ion. It has oxygen and then 3 hydrogens. Hydrogen ions in water mixed with basic compounds form hydroxide ions. That's OH, so it just has one O and one H. A substance is determined to be acidic or basic by placing its molecules in an aqueous or water-based solution. If it releases a hydrogen ion, H+, when it breaks down, it's acidic. If it releases a hydroxide ion, OH negative, when it breaks down, it's basic. pH is the power of hydrogen. It's the measure of the number of hydrogen ions in a solution. If we have a lot of hydrogen ions, the pH is very low. If there's a lot of hydroxide, OH ions, compared to the number of hydrogen ions, then the pH is high. So these ones would have low pH because there's a lot of H pluses here. This one has a high pH because it has a lot of OHs. Remember, if the pH is low, it's an acid. If the pH is high, it's a base. pH scale is used to measure the strength of acids and bases in a solution. It spans from 0 to 14. The middle point right here is neutral. It's neither acidic or basic. If it's greater than 7, it's a base. The strongest base is 14. If it's less than 7, it's an acid. The strongest acid is a 0. Indicators. A special type of compound that changes color as the pH of a solution changes tells us the pH of a solution. If you have a pool and you have to use the little tabs to test the water, those are strips. It's checking for pH. There are several different types of indicators. One type is litmus paper. In acids, it turns blue litmus paper red. And in bases, it'll turn a red litmus paper blue. That's our lesson there. Can you explain the differences between acids and bases? How are ions related to acids and bases? And determine an acid from a base using pH. If you can do those, great. If not, go back and look at the lesson again.